All right, now this slide we're going to talk about what happens when the impulse finally reaches the next neuron. So in my picture here, imagine what's going on here. This neuron right here has received a signal. It's been stimulated. So along goes the action potential all along and through here, and it comes to the next one. Now, making this connection to the next one, you have to remember that neurons do not touch. The connection, maybe there's a better term to use, but they really don't touch. If you look at this enlargement right here, here is the first neuron. They got the first signal. We call that the presynaptic neuron, because this gap right here is called a synapse. Okay, a synapse is the point where a one axonal terminal, transfers the impulse to the next neuron. The actual space is called the synaptic cleft. This whole area here is the synapse. And what happens is this. Along comes the action potential going down. When it gets to the axonal terminal, it's going to stimulate the release of a substance called a neurotransmitter. The neurotransmitter, and there's lots of different neurotransmitters, but the one we know the most about is called acetylcholine. Acetylcholine, let's just say that one here, acetylcholine gets released into this synaptic cleft. That's what these little green things are. When they come along here, they bind to the receptor proteins on the next neuron, or this is the postsynaptic neuron. The neurotransmitter binds, opens up a sodium gate, and in rushes sodium. So now sodium is going to be rushing into this postsynaptic neuron, or receiving neuron, and it's going to generate an action potential that moves all the way down again. Now, if the first one can transmit these neurotransmitters and stimulate the next neuron into an action potential, it's going to travel along at the same strength as the previous one. But the gap is the synaptic cleft. The whole union here between the presynaptic neuron and the postsynaptic neuron is called a synapse, and it's not very big. And as I put down in here, once the sodium gates have been opened up here, the neurotransmitter, something usually happens to it. Either it's broken down, reabsorbed, released somehow, and it causes the gaps to close here, so the next neuron only fires one time. Okay, if the gaps were left open, you'd have a continuous flow of sodium in there. You'd have a continuous flow of action potentials constantly being generated.